Okay, today what I would like to do is talk to you about the electron, and this is something we were building toward right before we had to work from home. So I was hoping to put this on the back burner until we got back to school. Unfortunately, that isn't going to happen before the AP test, so I wanted to now go through this with you as best I can from home. So as you'll recall, we had this gentleman, his name was J.J. Thomson, he was from Manchester. And in 1897, he had this device. It was called a cathode ray tube. This blue thing represents the cathode ray. They had no idea what these things were. They emanated from the cathode, which was the negative terminal. He accelerated these things using capacitors. He deflected them using electric and magnetic fields. And depending on the strength of the electric and magnetic field, he could deflect it up, he could deflect it down, or he could have it travel straight through. From this, what he was able to determine is the ratio of the charge to the mass of this beam. And he got this number. He really didn't know what all this meant, but it's going to become an important ratio later on. We saw this beam and this process in our classroom. Hopefully remember seeing this. And then hopefully remember right before we went out, we were doing an experiment, and it was a virtual experiment. We were doing Millikan's experiment where he had this little perfumed thing that he would squeeze and shoot oil into a chamber. He had an eyepiece which he was able to look at these drops of perfume, and actually they were drops of oil, and he was able to see how they behaved. He also had a capacitor in there, and he charged the bottom plate negative and the top plate positive. Again, he would spritz the oil into this chamber. If the drops were really large and had no charge, they would fall down to the bottom based on gravity. If the drops picked up a lot of charge passing through this opening, they would be attracted up to the top plate. And there would be some drops that would hover perfectly at rest in space. With these drops, we had equal forces of gravity down and force electric pushing up. So again, he would measure the voltage. He would get the electric field inside of there. He would find a way of figuring out the size of the drops. And he would compare force gravity and force electric. And for those drops that did not go up or down, force gravity and force electric should be equal. Again, he found a way to get the size of the drop. From the size and density, he was able to get the mass. From the mass, he was able to get gravity. From gravity, he was able to find electric. And from electric, he was able to find the charge. And the important thing is he did this hundreds of times. He got tons of data. This is not his data, but this is your data. And then what Millikan did is he sorted his data based on the charge that he got, and he found the pattern. And this is the pattern. So I want to take a look at your data. And when I zoom in on some of your data, I see clusters, and this is the important part. Clusters of charges that are all very similar. So I get a cluster around 1.6 e to the negative 19th. I get another cluster around 3.2 e to the negative 19th. I get a cluster of around 4.8. A cluster of around 4.8. And I get another cluster around 6.4. And what he realized is that these are all multiples of each other. He realized that he never got a charge less than this, e to the negative 19th, and he correctly inferred that this represented the smallest possible charge. This is called the fundamental charge. There's no charge naturally occurring in nature less than this charge. Okay, and this turns out to be the charge of the electron, the charge of the proton. We now know it as 1.602 e to the negative 19th. This was discovered by Millikan with this experiment. he recognized that these drops of oil had one extra negative charge on them. These drops of oil had two charges, two extra negative charges. They weren't neutral. This one had 3 extra negative charges. And these had 4, and so on and so forth. So what Millikan discovered is that these charges of these oil drops were quantized. You could never get less than a certain number, and you could then only get integer multiples of that number. You could never get 1.5 times that fundamental charge. Going back and looking at Thomson's experiment again, he had no idea what this cathode ray was. He was able to find this ratio, and now Millikan tells us that this beam was composed of quantized bits of matter, particles, if you will. Okay, and he found the charge of these particles was 1.6 e to the negative 19th. And with this and Thomson's ratio, we're able to now work out the mass, I should say, of these particles. So in essence, these two people tag teamed over the course of almost 20 years and were able to figure out the charge and mass of the electron. And more important, they found out that the electron was a fundamental bit of matter with a certain mass and a certain charge. Again, later we learned that the electron can also be viewed as a wave, a probability wave in certain circumstances. But again, there are circumstances where we can treat it like a particle with a certain mass and a certain charge. So I hope this helps to show you where we were going with that lab that we were doing. One of the most important labs that was ever done in physics. Again, not the one we did, but the one done by Millikan, which then helped the experiment of Thomson. So anyway, all you have to do today is go through this video, which you've already done. Hopefully you took some notes on it. Share with me the notes that you took, and show me that you can work with these ideas with a couple of simple math problems. Have a great day.